Hello everyone, I am Sabiha Jahan. Today I am here to present my findings on data infrastructure at Meta. Here is a detailed outline that we will be discussing further. Meta operates at an enormous scale, managing petabytes of data generated daily from its billions of users. To accommodate this, the company has built a complex and scalable data infrastructure. Meta deals with various types of huge number of data on daily basis. For the data storage purpose, Meta uses a combination of distributed file systems like Hadoop distributed file systems (HDFS) and object storage solutions. These storage systems are designed to handle both structured and unstructured data at scale. Scuba is an in-memory database Meta uses for real-time data analysis. Data can be ingested, added to the database almost instantaneously using Scuba. Scuba supports ad hoc querying, meaning users can ask any type of questions on the fly without predefining the query. Scuba is primarily used internally by Meta's engineers for debugging, performance monitoring, and troubleshooting. For the data processing task, Meta relies heavily on Apache Hadoop and Apache Spark for large-scale data processing. These frameworks allow them to distribute processing tasks across thousands of servers. Hadoop and Spark distribute data processing tasks across thousands of servers, enabling Meta to efficiently process massive datasets in parallel. Both Hadoop and Spark offer fault tolerance through data replication and are highly scalable, allowing Meta to increase computing resources as data commands grow. For ad hoc querying, Meta uses Presto, a distributed SQL query engine. Presto allows engineers and data scientists to run fast queries on large datasets without needing to move or transform the data extensively. For data management and orchestration purpose, uh, Meta uses tools like Airflow and Tupperware. Meta uses Airflow to schedule and monitor data pipelines, which orchestrates the flow of data between various systems. Airflow excels at managing task dependencies. Airflow's architecture is highly scalable, enabling Meta to run the data workflow across thousands of machines. It also provides built-in tools for monitoring workflows and sending alerts when tasks fail. Meta's container management systems, Tupperware, plays a crucial role in managing distributed applications, including those involved in data infrastructures. Tupperware automates the deployment, scaling, and orchestration of services across Meta's data centers. Tupperware provides service isolation. Tupperware integrates well with Meta's CI or CD pipelines, enabling continuous integration and deployment of new code. For real-time processing, Meta uses Pulsar and Kafka. Meta leverages these streaming platforms to handle real-time data feeds. Real-time processing is crucial for activities like updating news feeds, messaging, and ad targeting. Kafka is designed for high throughput and scalable data streaming. Meta's real-time data architecture is optimized for low latency processing to provide real-time insights. Pulsar's message storage and processing capabilities complement Kafka's strengths. Pulsar's geo-replication feature enables Meta to deliver real-time data to users globally by replicating data across multiple regions. Kafka and Pulsar are crucial in orchestrating real-time data pipelines and Meta. Data security and compliance. With such massive amounts of sensitive user data, security and privacy are top priorities. Meta has implemented sophisticated encryption and privacy preserving mechanisms across its infrastructure. Meta uses encryption to protect both data in transit and at rest. Meta implements role-based access control (RBAC) to limit who can access different types of data. Meta follows the privacy by design principle, embedding privacy considerations into every step of the product development process. To comply with privacy regulations, Meta practices data minimization. Meta conducts regular scrutiny audits and penetration testing to identify vulnerabilities in its systems. Meta has a dedicated incident response team that monitors and responds to potential security breaches in real time. One of the approaches Meta uses is differential privacy, a technique that allows them to gather insights from data while protecting individual user identities. Meta uses AI models for extensively personalizing experiences, improving content discovery and detecting harmful content. The data infrastructure is designed to support these machine learning models at scale. AI models built on Meta's platform are used for content moderation and enforcing platform integrity. AV is a machine learning platform built internally at Meta. It allows engineers and data scientists to train, deploy, and maintain machine learning models efficiently. AV automates the training, evaluation, and deployment of machine learning models. For scaling and optimization, Meta's infrastructure has been built to handle massive scale, but the company continuously innovates to optimize performance and cost. It employs horizontal scaling strategies, load balancing techniques to distribute traffic evenly across its servers. Meta employs data sharing, which involves partitioning database into smaller, manageable pieces distributed across different servers. Tools like Bearing J, a time series database, are used to handle the enormous number of metrics collected from systems and data. Now it's time for the open source contributions. Meta has a strong tradition of contributing to the open source community. Technologies like Apache Presto, RocksDB, and GraphQL were either developed or heavily modified by Meta engineers and have been made available for the wider developer community. Open source projects benefit from peer review and scrutiny from the global developer community. Open source contributions create a knowledge base that developers can access to learn from existing solutions, best practices, and case studies. Meta's commitment to open source ensures the sustainability and longevity of the technologies it develops. Now it's time for the conclusion. Meta is committed to innovation and open source contributions, sharing tools like Apache Presto, GraphQL, RocksDB to drive global progress in data infrastructure. By focusing on scalability and engaging with the developer community, Meta enhances both its own systems and broader technological advancements, fostering collaboration and sustained innovation across the industry. Thank you all for watching.